Hello and welcome back to this C# tutorial, and this is the third video. And as I didn't have time to complete the last video when I want to start with while loops, but it turned out to be too long for the previous video, I decided to split it up into two pieces. So this is the second part, and this won't be that long. So let's start this tutorial. I'm sorry. Let's see. So we want to start at loops here. I pressed the wrong button. But here now. So for loops, whiles, and do whiles. And basically, we need to perform a specific action given amount of times. We usually create a loop. That's basically the reason. And as you can see, as the title says of this presentation, we're going to look at for loops, whiles, and do whiles, and that is some of the examples available of the loops that you can use in C#. And if I just close this down a bit and navigate you to the reference booklet, you could find information regarding for loops and whiles and do whiles on page, I think it starts at, on page 5. And here, if you somewhere in the middle of the page, you will see some description and basically a reference if you'd like to go through it again at a later point. But now let's look at loops. One of the reasons to use loops is to solve tasks much quicker. So, I mean, instead of, as you can see, my example of writing from 0 to 99, and I basically want to write it 99 times, and as you can see, it would take a lot of time for me to sit and write each of these out. Therefore, we need to come up with some sort of shortcut. And in this case, we can solve this problem using loops. So basically, this is an example of a for loop. As you can see, we assign an integer value, I, and usually, because this can be any variable, you could have named this something else, but strictly speaking, it's really good if you name those variables I, which stands for index, j, or k. That's the variables that are mostly used in a program. And if you'd like to ask why we should follow those restrictions, I mean, it's nothing that affects the code, but it's something that really simplifies the interpretation of the code. And I don't mean the interpretation for the computer, but more interpretation for the one who will be going through your code. So if you're working on a big project, it's really good to follow those rules. But this is one of the rules I'd like to define today, at least. Let's go on. So if you look at this example, this is what I meant. So int I equals 0, and don't worry, we are going to go through variables and data types on a later point. But basically, this declares a variable, and these are the separators, the semicolons, and then we state that while, as long as this index is less than 100, and please really note that it's a less than sign, so it's not less than or equal to. So it will basically while until it comes to 99, and then it will stop. And the last statement, which sometimes might be referred to as a step. And basically what this tells the compiler is that basically it should increase the index, or the I variable, by 1 each time. Of course, this can be changed to increase by 2 or increase by 3. That's up to you to choose. But this is what really general example of a for loop. And then we can just use the I variable, which will basically, so I variable isn't a constant here. It's a variable that will change on each iteration. And every time it changes, we want to write the value on the screen, and that's what happens when we write console write line. So from the previous tutorials, console write line basically writes out specific text on the screen, and at this time we can refer to this variable. Okay, now let's go on. So basically, while as long as I is less than 100. That's the main expression here. And of course, you shouldn't forget about console read line. And this is nothing to do with the for loop itself, it's just to pass the application. So it's not that important for the actual loop, I'd like to say. And I think if you would like to see this code, you could also go to the reference booklet, and now let me, if we just minimize the application here, and if we would open the reference booklet again, and as I mentioned in other videos, you can always find the code snippets that I'm using in this presentation in the code reference, and this time I think you can find it on page 10. So here some of the examples, I think those were from other videos, and here there is an example. And basically, so reference 11, so let's try it and see what happens. It's always good to try and see what we'll get, and not just trust that it will work. Of course it will work, but just to see what will happen if we would execute this code. So once again, I mean the same way as we did before, create a new project, and depending on what version you're using, I mean Visual Studio version, you should follow the instruction on the screen. But basically create a new project, and here you're able to specify what kind of project, and as before, I'm going to choose a console application. And now let's instead of writing this out on my screen, I would like to just copy this, so let's do that to save us some time. Okay, let's have some fun. Let's see what happens. And yes, as I expected, all the values from 0 to 99 would be written on the screen. Notice here, if I would change the sign, and as we've talked in the last video about relational operators, if I would change this to less than or equal to sign, I would get something different. I would get the number 100 included in my result. That was kind of cool, I think. So let's now go to another part which I would like to talk about today as well. Whiles. And I think unless you need to, there is no reason to use whiles. Yeah, I think most of the cases you'll be fine with for loops. That's the ones that we've been looking at in the previous slide. So that's those kind of loops. Because these loops might turn into an infinite loop depending on how you're using it. And if you're skilled enough, you would probably don't make this mistake, but in the beginning I think it's really good to use for loops. But of course, I have nothing against whiles, but be careful when you're using them, because if you would just look at the if you just look at I is less than 100, this is a good, I mean, it's a valid expression, so it will work. But now, if you compare this to a for loop, where we actually needed to state how we would like to increase I variable, this time we need to do it manually. So we need to go into the code and we need to manually put I++ here. Really important, I think, because otherwise I will not be increased, and that means I will always be less than 100, which we actually don't want the while the I to be, because otherwise, yeah, we'll get an infinite loop, and that means the whole application will just crash. That's not good. And by the way, this code is actually, you can find this in ref 12, so it's on page 11. Let's now take a deeper look on that as well. And I would so page 11. Now I would like to show you some of the interesting stuff we can do with whiles. And before I start with that, I'd like to add to the things I said before. The whiles, they basically give you a bigger opportunity in a way that you can decide if you'd like to have I++ after the expression or before the expression. That's one of the things you can decide. But of course, as I said again, everything that can be done with whiles can most likely be done with for loops. So that's really important to notice. But now let's go back again. I'm sorry for going back and forth, but here's the code. I can probably zoom in so it's even more clear on the screen. So let's try and see what happens. Once again, I compile, and I basically get the same thing. I get values from 0 to 99. That's what I want to get. And actually, we can now change I++, because I mean I++ is the same as plus or equal to I, or plus or equal to 1. Let's look at this again. And if you don't know what I plus or equal to means, that's the same as saying I is equal to I plus 1. That's the same way of telling this. So basically, just a shortcut. Once again, there are a lot of shortcuts in C# and other languages as well. But what we can do now, instead of having an increase by 1, which is constant, we can't change it. We can basically, in this scenario, we can actually change this to something else. We can change it to 2. Now I'd like you to think, what will happen if I change this to 2? I'll give you some time. Yes. So the thing that will happen is that you will get even numbers. And this is really, I think it's really obvious, because we want to get each second number from that list. So basically it will increase by 2, and of course then we will have all even numbers. However, the same thing could have been achieved if I would return this to replace this with 1 again. Or no, let's make it even more as it was before, I++. I mean, the definition of a even number is basically when 2 times an integer. And here I have 2 times an integer. So this is another way of getting all of the even numbers. And now you can see we'll get twice as much because we have extended the set of numbers. I think that was really interesting, I think. Let's now go on and look at the third kind of loop. And this is the kind of loop that, if I was a bit suspicious about this one, I would say that this is even more I don't know the perfect word for this, but basically this is something I really want to use. I mean, you can now we return to this thing that, I mean, everything that you can do with whiles you can do with do whiles and vice versa. So there is no point of using do whiles. I mean, it's the same thing, but the state expression will be checked at the end. So basically, this application. So if we start here from above, we set I to be equal to 0, and then we create a do loop, and then basically the application will just jump into the loop, and it will not look at this expression. So it won't. If you would compare this to this example here, before we enter this loop, we will check if this statement, or if this statement is true. If it's true, we're going to execute the statements inside this while, and it will basically end once this expression is false. And here it will automatically jump into the while or do while, execute the statement, and then it will check for the expression. And if it appears to be true, and basically the same way, the same concept apply here as well. And in order to show you some of the differences, so I mean, I'm probably going to leave this to you as an exercise. If you look at reference 13 on page 11, you'll be able to see some of the you'll be able to see the do while in action. Just copy the code and put it into your project. But this is an exercise for you. I'd like to jump to reference 14, and this is a comparison I've done to show you the difference between whiles and do whiles. I'm going to copy that code and I'm going to paste it into my application. And now let's look at this. We have two whiles. So here, while 2 equals 3. Of course, we can see it's not true. Here, by the way, we have the same thing. 2 equals 3. That's not true. Let's now hide this while. And one way of hiding or commenting out the loop is to press comment out the selected lines or Control K, and we have commented out this piece of code. Now let's execute. And obviously I don't get anything, because I mean this is not true, so it won't write out what we wanted to display on the screen. Now let's do the same, but for the while loop. Let's comment it out, and if I want to uncomment something, I press a button which is beside the commenting button. So let's debug it again. And now you can see, although this statement is false, we are still able to see the text. And this is basically the difference between whiles and do whiles. And as I said, you can always work with for loops and while loops, but in some cases you might need to use do whiles, depending on your task. So this is just one of the ways we'd like to show you. And basically I think we've talked about this. So whiles and do whiles are almost the same thing, but the main difference is that whiles look on the statement before they execute the code inside, and do whiles do not. They look at it afterwards. So as a summary of this, and actually the previous video, because the previous video is a part of this lesson, we've basically looked at relational operators. That's one of the things. Relational operators, as I said, can be found at page 3 in the reference booklet. Page 3 in the reference booklet. So it's here. Basically, this is like a summary as well, so you don't need to use the presentation itself. We've looked at if statements. So how you can set some conditions. So if this is true, do this. If it's not, do that, and those kind of stuff. That's if statements. We also have logical operators, and we've been looking at those. So, and in this particular video, we have investigated loops, whiles, and do whiles. And as I said, for loops is the best option, but of course you might want to use whiles and do whiles in some other cases that fit your solution. So I think once again, thank you very much, and as a cliffhanger for the next video, basically that video will be about data structures, where we will look at variables, arrays, and data types and primitive types, and those concepts will be examined in the next part of the video, or the part of the course. Once again, thank you very much, thank you for watching, and have a great day. Bye.